All right, everybody, welcome back to Data Programming 1. Today we're going to be talking about tabular data, but I just have a couple of things before we get into that. First, please remember that don't post any questions on Piazza about the exam yet. If you do have questions, feel free to bring them to office hours, or I suppose make your post private, because we still have people after the disaster last weekend who are trying to take the exam. We plan to release the answers on Friday. Everyone should be done by then. So until then, please refrain from leaking information to those students who haven't taken it yet. All right, next up, a couple of things we're going to need during the lecture today. Let me switch over to our web page. All right, so here we are today, CSV tables, October 7th. There's two things here. First, go ahead and download the slides and open those up. It's a PDF document, but we're going to be copying and pasting some very important code as you guys go through this. And this code you will need for examples for the next 5 weeks, okay? The other thing, you also need it for the projects. So it's in the slides right here. I'll show you exactly where in the middle of the lecture when we get to that point. But go ahead, download that, have it open and ready to go. The other thing we're going to need is a piece of code from the code folder. So I'm going to open this up under files right here. So you can see the lecture code is the code that Mina has already prepared for her lecture. She beat me again. And here's the notebook. Under files, though, we've got a number of data files that we'll be using. The only one we need for today is restaurants.xlsx, the Excel file. Go ahead, download that. We will be using all of these over the next couple of lectures. So if you want to just go ahead and download all of them right now, that's perfect. The bottom one is the one we need for today. All right, so I'm going to go ahead and start off with a little bit of review. So last lecture we were talking about lists, and one of the examples that I didn't get a chance to do using lists was computing the median. So the median is, as you guys may remember from math class, it's the middle value. If I take all of the values in a list, I sort them and I find the middle one. So it's a little bit different from average, where I would just add them all up and divide by the number. And that third thing you probably learned the same week in algebra is the mode. That's the one that appears most common. We'll come back and do that in a different example in the future. All right, so here's what we're doing today. We're going to be computing the median, and I'm just going to write a function that does this. So we'll define a function. We'll call it median. We'll need something right here and in a colon. And for now, we're just going to do nothing. All right. Now, for the rest of the example, I'm going to need to test it with some numbers. So I've got some numbers. We'll just call those nums. And again, I'm making a list, and it's going to have more than one item. So I'm going to use a plural variable to remind myself that this is a composite data type. All right, and then we'll just throw some numbers in here. -2, need some commas, -1, 30, 20, and let's see, to make the math easy, 3. Okay, so that they add up to 50. I've got 5 numbers. Average should be 10. We're not doing average, we're doing the median. So let's see, the median in this list, if I sorted them, I'd have -2, -1, 3, 20, 30. The median should be 3. All right. And then I'm just going to call my function. And I'm going to need to give it the list of numbers. There we go. So we'll call that with nums. And that means that I'm going to need a parameter right here because I'm passing in my list of numbers. And could call it nums, but that might be confusing because I'm using the same variable twice. Nothing wrong with that. I could easily do that. But I might have other things I'm taking the median of too. So we'll go ahead and we'll call this items. I think that's the same variable name Mina used. We'll see. All right, and just to get started, I'm going to print something just to make sure that I haven't screwed up anything yet. So I'm going to go ahead and run this cell, and it looks like it's good. They didn't give me any error messages. It printed out the list just like I was hoping. So the median is, of course, the middle number in the list when they're sorted. So the first thing I need to do is sort this list of numbers. And you might remember from last time that sort was one of the functions, one of the methods available for lists. Items.sort, we'll go ahead and call that. If we run this, we now see that it's taken the list of numbers and it's sorted them. So I've got the -2, -1, 3, 20, 30, exactly like I would expect. Still printing them out. After that, I need to return the middle one. So I'm going to go ahead and just return, and I'm going to hard code this for right now. Items, and let's see, this is index 0, 1, and 2. So the very middle one is going to be index 2. Okay, since I'm returning something, I'm going to capture this in a variable now. I'm just going to call it m, short for median, and then we'll just write this out. And that will go in the out box. So check this out. I've gotten, just an aside here, a valuable tangent. I've got a number of questions during office hours about how the grading script works and what's the difference between printing stuff and this out box. So we've got 3 zones here. First, we've got the code writing zone. We've got the printing zone where I've printed the list. And then the very last thing, and this is a feature of Jupyter Notebook, not Python in general, is that I can take a variable, put it in the last line. Jupyter's going to go get the value of that and put it in this out box right here. This is what our grading script is checking for. So if you don't have anything in the out box, you'll need to do that. And if the test script fails, it's likely coming from right here. Okay, so anyway, just an aside. All right, I've got some problems with this. It works great for this list. It works great for any list that has exactly 5 numbers in it. But the moment I start adding more things, let's put 88 and 99 in here. If I run this, it's no longer giving me the right number. So now 20 is the median value, but it's still returning 3. And that's because I hard-coded index 2 right here. And in fact, if I only had 1 item in the list, the median value is that 1 item, this would totally crash because there is no items 2. All right, so here's what we're going to do. We need to come up with a better way to find the right index. So I'm just going to go ahead and add one more variable. We'll call it the middle index, and that will be, let's see, it's going to be items dot length. I'm doing that backwards. Length of items, but I don't. So this list has, let's see, 1, 2, 3, 4, 5, 6, 7 items in it. I want to divide by 2. That'll give me, let's see, 7 divided by 2 is going to be 3. Remainder 1. So the integer division here will give me the 3, and that should be the right answer, I think. 0, 1, 2, 3. Whoops, 0, 1, 2, 3. Yeah, that should give me 20. So I'm going to go ahead and now put my middle index in here instead of the 2. Run this and make sure that we're getting 20. Perfect. Let's add a couple more numbers. Oops, add in the wrong spot. Let's add 5 and 6 to this. See if we're now getting, yep, looks good. Looks like this is working. But we are going to run into one little problem if we have, so this, all the things I've tested so far have odd numbers of elements. And so there's exactly 1 middle. But what if I have an even number of elements, like 1, 2, 3, 4? The median of this is, well, here, let's just run the code and see what it does. It's going to return 3. So it's going to take 4 items in the list. Integer division divided by 2 gives me a 2. And so it's finding element 0, 1, 2 right here, that 3. Doesn't matter what order they're in. I'm just going to leave it like this while I'm testing, and then we'll try some other mixing it up. But this isn't the right answer, because the median of a list with something that's even, I'm going to need to take the average of the 2 closest to the middle, the 2 and the 3. So the answer should be 2.5. This code is inadequate to get that. It works great for odd numbers of items in the list, but not great for even. So I need to upgrade this a little bit. Let's go ahead and just, yeah, this part's working. Those 2 lines are great, but I need to know this only works for odd numbers. So we need an if, let's see, length of items, mod 2 exactly equals 1. That means we have an odd number of items. So this is, we're going to divide by 2 and give us the remainder. If the remainder is 1, it has an odd number of things in it. All right, let's see. If statements need a colon, and we need to tab this stuff over. All right, so that's great if it's an odd number. Then else, and I don't actually technically need to write this else because I've got a return here in the if statement. So this automatically will be fine. I don't need the else, but I think I like the way it feels because there's only 2 choices. It's either odd or even, so I'm going to leave it with the else. Maybe I'll write the code and then show you what I really mean when I'm done. So to get the median of an even numbered list, I need to take the average of 2 numbers. So the first number is going to be, we'll do a little math in a second, and the second number we'll do a little more math in in a moment. Okay, so the second number, this was actually giving me the 3 when I did exactly this. So I'm just going to copy and paste that. And the number right before that, I need the 2 in this case, is going to be divided by 2, just 1 sooner than that. So just subtract 1 from that. And then I'm going to return the, let's see here, items of first plus items second, and you divide by that by 2, and this all needs to be in the numerator, so I need some parentheses around that. Okay, so this part right here will go get that first item, and that's going to be the 2 in this example. Then it'll get the second item, the 3. We're going to add them all together. That's the entire numerator. We divide that by 2 because we're taking the average. And this one needs to be the not integer division, the single slash. When we run this, alright, what did I screw up? Okay, cool. That was dumb. So check this out. Let's go ahead and read the error message. This is a mistake I'm going to make all the time, and you guys will probably too. So when I look at the error messages, it's a type error, so I've got the wrong type somewhere. The trace back is just all the steps backward from where the error happened. So it's telling me right here that the error is in cell 9. That's 9 right there. In this line, m equals median.num. So that's right here. I'm calling the function median. So the next block down goes into median, and it's telling me the mistake is in, well, first, still in cell 9. The mistake is right here on this line with those arrows, and I'm calling a function here. I'm calling a function called items because I've got the curly parentheses, or the smooth parentheses, not the square brackets. So I'm trying to index into a list with the wrong kind of thing. And the error message I get is list is not callable because it thinks items is a function because I'm using these parentheses. So let's go ahead and get that fixed. Put the square brackets in. Try this again. All right, awesome. Looks like that worked. So now I'm getting 2.5 exactly as I expected. All right, I'm just going to take a moment now and try and break this. What can we do to, oh, I also told you guys I was going to go ahead and remove this else. This line is not necessary, and I can just tab these over. If this happens to be an odd number of items in the list, then it'll do these 2 statements. And if not, it's going to go ahead and do those 3. It'll just skip those 2. So if it gets to this point right here on line 8, it must necessarily have an even number of items in the list. If it has an odd ones, it's going to hit this return, and it will never get to this code right here. So this also works. I've got 2 different ways I could write this. I just wanted to demo that. My personal preference is to include the else because I feel like it makes it clearer and more organized. So I'm going to put that all back. Yeah, it's like making the blocks for odd and for even. All right, cool. All right, back to breaking. Let's try a couple things. Let's try a really short list. All right, so if there's 1 item, it should find that. If there's 2 items, it should find the average of those 2. What if there are no items? Okay, it crashes. Let's take a look at this error message now. I'm still getting, oops, it's an index error this time, not a type error. Traceback just means it's going to be going back through. The error happened when I called function median in cell 13. Note, every time I run this, it updates which cell it is, and I don't have to run these in order. I can move around, and it still will just, it keeps track of the order that I run them in, not the order they are on the page. May be useful. That's why kernel restart run all is very valuable when you're like debugging your projects. Okay, and it's telling me that the problem is right here in this line. I'm indexing, so the length of the list is going to be 0 here. I do some math, divide that by 2, subtract 1, so I've got an index of -1. Perfectly valid in Python. That should be the last item in the list. However, the list is empty, so this list index out of range, there is no last item. So that's the problem right there. So I cannot index into an empty list. All right, some other things. Let's see here. That was an empty list. Let's try A, B, C. See if we can find the median of this. It's going to return B. Let's go ahead and mix those up a little bit. So if I put the C in front, then it should sort them. I should still get A, B, C. But then it should also return B again. Let's try that. Yep, so it sorts them A, B, C. What if I throw in some capital letters? We'll do that. Yep, that's going to put the capital letters first. Find the middle index. So there is a little problem with this. This is kind of surprising that it works with letters. But if I put in one more letter so that I have an even number of letters, when I run this, it's going to crash. What it's doing is it's going to sort the list, it prints it out, and then it's trying to find the average of capital C and lowercase a. And that sort of math, like right here, is not supported for strings. I can't do can't just take the average of two numbers. So item first plus item 2 for strings, that's going to concatenate them. So this will give me capital C lowercase a, but I can't divide that by 2. All right, so back to today's topics. Tabular data. So these are going to be just data that comes in tables. So and in particular, we're going to be focusing on CSV formatted data. That stands for comma separated values. It's a pretty standard way to just put a table into a text file. Let me just go ahead and point out too that the reading that goes with this is chapter 16 of the Swigart book. That is the Automate the Boring Stuff. It's chapter 16 in the second edition. It's chapter 14 in the first edition. So if you just go to this link, in fact, all the links on our webpage go to the first edition because we're lazy and didn't update them yet. But it's actually the same chapter. He just added some other material in front of it. So it doesn't matter which one you go to. All right. There's going to be some stuff in this chapter because it's sort of near the, it's not right at the beginning of the book that we haven't covered yet. Just go ahead and gloss over the stuff and focus on the CSV file in particular stuff and how to read the data from a CSV file. All right, let's begin with a discussion of spreadsheets. Spreadsheets are a way that a lot of people are familiar with organizing data into tables. So just let's start with a little vocabulary too, just to make sure that all the words I'm using everyone's familiar with. So all of the data in the spreadsheet is going to be organized into cells. Each one of these little things is a cell and contains some data. Columns. Yep. So the cells are organized into rows and columns. So columns are just cells that are stacked on top of each other, and rows are going to be cells that are next to each other. Spreadsheets may also have a header row. This is going to be a row, usually the first one, that doesn't actually contain any data, but instead contains something that describes the data in that column. So like column B here has the header year in row 1, and the rest of these are actually data items. They are the years that those hurricanes take place in. This is from an early version of the project, so the data you guys were working with for the hurricane project looked a little different, I think. All right. So spreadsheets also let us do a lot of cool things. We can put in different kinds of data. We can put in text. We can put in numbers. We can put in formulas and equations and let it actually do the evaluating for us. Python gives us a lot of control over doing that kind of stuff. Also, let's see. Yeah, here we go. Fonts. So we can format the data, look a certain way. We can put borders around the cells. We can color code things in a spreadsheet. And we can have multiple sheets of data, multiple tables, all in the same spreadsheet. So right here, I can just keep adding more. All right. There's some downsides to using spreadsheets, like Excel. They're binary formatted data. So when you save something from Excel, it's just going to translate all of the data that you were working with into ones and zeros, and basically to compress it, they store a lot of extra information about the formatting and things. But it's going to mean that if we try and read out the file with cat, it's going to be not human readable. When cat tries to translate all of the ones and zeros into characters, it can't do it. So we just get garbage that's impossible to read. So reading Excel files into Python is really tricky without very special modules. You're best off just using an Excel file in Excel. All right, so CSVs to the rescue. stands for comma separated values. They're a lot like simplified spreadsheets. We're still going to have all of the data organized basically in cells and rows and columns. Some of the simplifications things that go on is we only get one sheet per file. So if we want to have more than one sheet, we'll just have to have more than one file. All of the cells only hold strings. Everything will be a string. So even the numbers, it's just going to be a string of digits, a bunch of characters. And if we need it to be a number, we'll have to convert from a string to a number. And if you don't remember how to do that, it was very simple. It's just the name of whatever type I want to turn it into. So if I want to turn it into an int, it's int. And then you put the string in parentheses. So we'll be doing lots of that during the examples, so you'll get a quick review every time I do an example. All right, and finally, there's no way to specify the font, border, cell size. We can't put formulas in them. It's just going to be the data. All right, some of the good news is these are all plain text files. So if I go ahead and use cat to read them, it just prints out the data, easily readable by a human. So I can see I've got Hurricane Baker in 1950. I've got my header row, name, year, miles per hour. It's not like got a lot of spacing in there to make it look good, but plain text, we can read it. That also means that writing code that understands CSV files is also pretty easy. And we can pretty much use any text editor we want to open these. Notepad, TextEdit, Idle, Jupyter Notebook, they're all good. All right, so the basic syntax, the vocabulary I just used still holds. I've got a table here with my data. I have a header row with the names that describe the data in the columns. So date describes the numbers here. So 1967, October 19th. In the CSV file, it's going to look like what we have on the bottom here. So the header row is encircled in red. The red box, we just still have all of the same words separated by commas. What we see is that each row in the CSV is one line in the table. So the header is the first one, and then each one of these rows, like the second one here is the first row with data. Heidi, 1967, October 19th. All that here, all that is in one row. All right, the cells are separated by commas. There we go. There's the commas. And all those commas are going to separate the data into the columns. So it shows me which piece of data goes in which column. All right, so characters that act as the separators, they're known as delimiters. So we were using commas to delimit the cells in each row. And we've got new lines to separate the rows. So that we would say that as new lines delimit the rows. All right, so there are some things that make working with CSV files potentially challenging. For the very simple ones we've just seen so far, none of these issues come up. But what if we want to have a cell that does contain a new line in it? So new lines are the delimiters for rows. But if I have a cell where I do want a new line, that's going to be a complication. If we want to have a comma inside the cell, how do we take care of that? Because commas are used to separate cells. But it's totally possible I might want to put a full sentence in my cell, and with punctuation, maybe a comma. The answer there is we're going to use quotation marks to indicate that basically the new lines and commas are not part of the structure of the CSV, but are actually part of the data. And that brings up the question, what if the cell actually contains a quotation mark? And what if we want to use like different delimiters? Tab separated data is also very common. They're still called CSVs, but other delimiters may be used, spaces, tabs, other things. So what we're going to be doing in this course is to use the general CSV module available in Python rather than writing our own. All right, so next up I want to go into actually taking an Excel spreadsheet, turning it into a CSV file, and then using that CSV module to bring it into Python as a list of lists. So we'll see as we have a list, the outside list will be a list of rows, and the inside list, that second list, will be all of the data in each row. And we'll go through a bunch of examples. So to start out, we'll have a spreadsheet in Excel. This is the one that, the hurricane data in Excel format. And we'll just go ahead and save this as a CSV. Excel makes it really easy. I can just go to File, Save As, and select CSV. And I'll demo this when I get to that the restaurant one, the restaurant demonstration at the end of the lecture today. So we save that CSV somewhere in a file, and it's going to look something like this. It's going to have all of the data from the header, and then all of the data in rows just separated by commas. All right, next thing we're going to do is we'll use that module to read in the data. And this code that reads in data from a file and puts it into a format that Python can use, the list of lists, so is known as parsing code. And by list of lists, here's what I mean. The outside brackets, there's one right here, one right here. Tell me I've got a list. And then the data items in that list are the rows. So each row is also going to be a list. So I've got brackets here to indicate the first row, the header. It's got the name, the year, the rest of the data. I didn't put it all in. And then comma separating the next row. This is going to be the first row of the data set. So it's got all the cells here separated by commas, Baker, 1950, the rest of them. So coming from right here. And this is probably kind of a good chance to just review and make sure that everyone understands what's going on. If I have data like this, if I read my file into a data structure called rows, it's going to be a list of lists. And if I have something like this, rows, bracket 1, bracket 0, the way I'm going to read this is rows of 1 of 0. And this is going to tell me that I'm looking at row 1, item 0, column 0. Yeah, row 1, column 0. So to figure out what this is, I've got 4 examples here. We'll just go through. So row 1, so this is actually row 0, the header. Row 1 is going to be this row right here. And item 0 will be Baker, just like that. All right, cool. Next example. Rows 3, 1. So rows of 3 of 1. I don't have enough here. I've got to go down here and see. I've got row 0, 1, 2, 3. Should be Eloise, right? Nope, wait. 0, hold on, where's the mouse? 0, 1. Should be 1975. I'm tripping myself up. Okay, cool, 1975. And I've got that in red down here to sort of highlight where that's coming from. All right, next up, rows 1 of -1. Okay, so row 1, here, this is row 0, this is row 1. The -1 means that we're just going to take this list and go to the last item in the list using that negative indexing method. Should be 38. And there it is, 38. Coming from right here in red. Final example, row 0 -2. Let's see here. So row 0 is going to be the header row, the top one right here. -2 is going to give us, well, -1 would be deaths, the last item. -2 will be damage. Next one over. There we go, damage. All right, next up, let's take a look at this parsing code. This is the code that's going to take the text file, the CSV, and read it directly in and give it back to us in a form that Python can use. So let's take a look at what this looks like. This is an example copied from Swigart's either chapter 14 in the first edition or 16 in the second edition. It's in both of them. They're the same. And this is the code he's using to read in a CSV file. We're going to want to use this parsing code over and over the next like 10 weeks of the course. So I'm going to go ahead and develop this into a function that we can use to basically read in any CSV file. And you guys will need this function throughout the semester. So stash this somewhere, save it, just set it aside, and realize you're going to be copying and pasting this in to most examples that we do for the rest of the semester and pretty much every project. So let's go through this. It's not necessary to understand exactly what's going on with this, but by the end of the semester, you guys will. But for now, note that all of the stuff we need is going to be found in the CSV module. So we're going to import that. He's opening the CSV file, creating something called a reader from the CSV module, or calling the reader function from the CSV module, giving it the name of that file that he's opened, and then turning it into a list. And example data here, if you print it out when you're all done, is a list. Whoops, example data right here is a list of lists. Man, put the right words in, Mike. Okay, list of lists. So the CSV file looks something like this. I've got here date and time, apples, and a number 73. So each of these is some sort of data about timestamp, the name of a fruit, and an integer. So we should see that there's 3 items in each of these lists. So like this one right here, we've got the timestamp, the name of the fruit, and a number. All right. So what I want to do now is talk about how I'm going to turn this into a function so that we can use it sort of more generically for any CSV file that we want to read in. So the first thing we're going to do when we generalize this is identify a couple of key things. The input is example.csv. That's his CSV file that he's going to be reading. So we'll need to replace this with a variable so we can use any file name. And it's returning example data. So this is the list of lists that it's creating. So this will be our output. Now, I've got my input and output, and I know how to use those. It doesn't matter what the rest of these lines do. I don't need to understand to be able to turn this into a function. So first thing I'm going to do is I'm going to shove all these over with a tab and add my function definition up here. So and I'm calling it process CSV because it'll take pretty much any CSV and process it and turn it into this list of lists. All right. Next, it's not good practice to import in the middle of a function. We should have all of our imports up at the very top of the file. So we'll just go ahead and move that to the top of the file. And recognize that when you guys copy and paste this stuff, this function in and use it in future assignments, you'll need to remember to do both the import CSV and copy and paste the function. All right, next thing, we need to be able to get the data back out. So in this case, we'll be returning the example data. The function is going to create a list of lists and return that. So we need to get it out. And the next thing we need to do is generalize the input. So this is hard-coded for example.csv. We don't want that. We want to actually use a file name that we give to the function. So we'll put in a parameter. I'm just going to call it file name. And then we'll replace that hard-coded example.csv with the file name. And finally, we have to remember to cite all of the code that we ever use from anywhere. So in this case, this came from Automate the Boring Stuff, chapter 14. That's the first edition. If you guys find some code online, for example, if you looked up how to compute the median, you find some general code on Stack Overflow, it's totally okay for you guys to use that, but you must cite your work. You must give me, and this is exactly how I want it. Comment, copied from, and then just give me the address or the URL where you copied it from. One little caveat there, if the project gets leaked online and someone posts all of their answers to GitHub and you go and find a very specific answer to our questions, please don't copy that. All right. This is the slide. So if you open up the PDF, you can scroll down to, I had to go look it up. Yeah, scroll down to slide 44. This is the code that you'll be copying and pasting into the Jupyter Notebook or whatever idle as you write things that use CSV files. So this is the one. Hang on to this. I've added a couple other little details right here. The encoding UTF-8, that makes it work on Windows. And it's important that we close the file. We opened it here. Need to close it. All right, so next up, I want to just wrap up today's lecture with an example. And the one I'm going to do is I've got a CSV that's got a bunch of restaurant names and their XY coordinates. And these are in blocks relative to the computer science building. So X and Y coordinates for some of my favorite pre-COVID restaurants. And I don't even know if these are still open. I haven't been downtown since March. So anyway, I've got the set here, Steenbox, Subway, McDonald's, and Greenbush Donuts. That was one of my favorites. All right, so here's the idea. We're going to be taking and writing a little Python program that's going to take the name of the CSV file, and we're going to give it a restaurant name, and it's going to print out the coordinates. So this is a program that we will be running from the command line. I'm going to be using PowerShell. If you're watching Mina's lecture, she's a Mac user. I'm sure she's using Terminal. Either way, it doesn't matter. You'll just go to the prompt, and I'll demonstrate this. But you type Python. We're going to give it the name of the program we're writing. I'm going to call it R lookup, short for restaurant lookup. And then I'm going to type the name of the restaurant that I want to know the coordinates of. So we're going to learn a couple of things, that not just using CSV files, but this seemed like a good day to also bring in. These are called command line arguments, where I give Python extra information that this program is going to use. All right, so let's get started with this. First, I'm going to open up my working File Explorer. If you're working with a Mac, navigate to your folder where you've got the Excel spreadsheet. I'm just going to go ahead and convert this into a CSV. So if you want, you can follow along. Or the CSV is also available in the code directory. You can just download it directly. So first thing I'm going to do is just open this up in Excel. Let's move this back over so everyone can see it. And like before, it's just the names of a bunch of restaurants and X and Y coordinates for those restaurants. And this is blocks relative to the computer science building. We do not have a header row. It's just the data, and that's okay. So here's what I'm going to do. I'm going to just go to File. We're going to Save As. And then, yeah, restaurants is fine. But I want to save it as a CSV file. And Excel is a little tricky. I don't want this one. I want the plain, boring CSV like halfway down right here. That's the one I want without anything else going on. So there we go. It's going to save it in lecture 14 where I'm working today. There we go. So it's now been exported. It's going to let me know that some of these features we lost, like the coloration and the bold on the font. Yep. Now I need to go back here. So I see I've got my CSV file. And I'm going to go ahead and open up. So Shift right click anywhere on the screen will give me the power to open up PowerShell right here. That's what I want to do. All right. And just while I've got PowerShell open, let's just cat restaurant.csv, and we can see that all of that data is in there. Cat just reads out the file. We can do the other file too, restaurants.excel, and we can see that it's this garbage gibberish. I don't know if you guys heard that, but it just chimed. It gave me a like nasty sound from my computer as I try and print out characters that are actually associated with noise, like the alarm bell, because of the weird way that the binary gets decoded. All right, cool. So next up, what I really want to do though is we're going to go ahead and write some code. So I'm going to go ahead and open up. I'm going to do my idle. If you're on a Mac, it'll be idle 3. And what did I say? Name this our lookup.py. Pretty sure that's what it was. Okay. And now we got everything side by side, looking good. All right, so the first thing I want to do is actually copy and paste my function that's going to read data files over into my idle window. So I'll just bring that in right here. All right, so let's get started by actually reading in that CSV file with all of my restaurant location data. So to do that, I'm just going to call the function process CSV. And now I need to give it the name of the file, and it's going to be a string. Restaurants.csv is the name, and idle's smart enough that when I start typing, I push tab, it's going to look in the current directory for any files that start out like that. And then let's see here, we'll close that up. This is going to return a list of lists. In this case, it's called example data. I want to capture that, and I'm going to go ahead and call this rows to remind myself that this is just a list that contains all of the rows of data. And just to make sure this works, let's go ahead and print this out. Print rows. I'm going to save this. I'm going to go back over here and type Python, and then we'll call our lookup.py, and it should print out my list of lists. All right, awesome. It's kind of hard to read. It'd be cool if each of these got their own line. So let's go ahead and upgrade this a little bit. So instead of just printing out the list of lists, I'm going to print them out one row at a time. So I'm going to iterate through all of the rows, and I've got 3 choices. I've got 3 different kinds of loop I could use. This one is going through data, so I'm going to use the iterator for loop. So for, and I need a name of a variable, so I'm going to call each of the rows. So it's going to go through the first row. I'm just going to call it R. So for R in rows, so the first time through the loop, R is going to be equal to this very first row. Over here, it's going to be the McDonald's 4-3, that row, and it should print it out. And then the second time through, it'll be the Subway row. All right, let's go ahead and save this. I'm going to go back over here, run this again. Actually, this is a little messy. Clear. Now we'll run it again. Let's see, what are we doing? Oh, I didn't change to print rows. I'm printing out the entire data, rows, every single time. Not what I wanted. All right, that should help. clear, and run it again. There, that looks really good. I love it. That's great. All right, what this program is going to do in the end is I'm going to give it the name of a restaurant, and it's going to print out the location of the restaurant, the coordinates. So eventually I'm going to upgrade this to use the command line arguments. But for right now, we're just going to hard code the name of the restaurant we're going to search for. I'm going to put that up here, call it my search term, and to get started, we're just going to search for Subway. So we'll put in the string Subway, and this is just my test. As soon as we get this part working, we'll take this out and go ahead and use the command line arguments. Okay, so as I go through this, instead of printing out the rows, what I really want to know is, well, I want to find if this row corresponds to Subway. So in this case, I've got the first row. If R, this is going to be an entire row. First time through, it'll be the McDonald's. If R, and I don't want the whole row, what I want is just the name of the restaurant. So that's going to be in position 0 of the row. So the first time it'll be McDonald's. So R without the index gives me the whole thing. R with index 0 gives me just the name. And I want to know if this is equal to my search term. Then we'll print it out. All right, does that look good? So we'll save this. Clear, run it. This should just print Subway. If I don't have any typos. Let's try this again. Didn't print anything. It's supposed to print the row. Hold on, what did I do wrong? Timeout. All right, I figured it out. So check this out. I went ahead and added a just print out the name of the restaurant for each of the rows. And then I came over here and noticed that Subway is capitalized. And it's not right there. So we just need to upgrade that like that. I'm going to just make sure this works. Yep, there we go. So now it's printing out the Subway row because it is capitalized. All right, cool. Now that's not exactly what I want the output to look like. If you remember from the slide, let me pull this back up. What I want it to do is print out x equals, well, for Subway 1 and y equals 0. So let's go ahead. See, this was what tricked me. I've got the lowercase Subway right there. All right. Let's go ahead and pull that back up. There's that and that. So instead of just printing out the entire row right here, what I really want to print out is the string. Let's see, it's going to look like x equals, and then I'm going to go ahead and use that format method from strings so that I can just put in everything all in one row, and then y equals, and then the to be replaced dot format. And let's see here. Now the data that I want is going to be in row, and it's going to be in position 1 for the x and row position 2 for the y. And then I need to close up the parenthesis for the print statement. I can get rid of that. It's not working. And let's just give this a try. Figure out where I made mistakes. Oh, I didn't. Check that out. It totally worked. X equals 1, y equals 0. Exactly like I wanted for Subway. So at this point, demonstrated reading in a CSV file using the CSV module and the code from Swaggart, upgraded to a function. We got a little bit of a review with lists of lists and a little bit of review with the string formatting. Next thing I want to do is I want to introduce one more thing, and that's going to be the command line arguments. So to use command line arguments, they're going to be available. They're part of the sys module. So I'm going to import the sys module just like that. Next thing, I'm just going to go ahead and print out the command line arguments just to do a little exploring, a little experimenting. So I'm going to print them out. So command line arguments are stored in a variable called argv. So command line arguments, arg comes from the arguments, and v stands for the values of those arguments. So I'm going to print them out, argv, and then they're stored in the sys module's data, argv. So we'll just see what this looks like, and then we'll just go ahead and run the rest of the code. So it'll still print out the coordinates for Subway. I don't think I saved that. Now Python r lookup, and I'm just going to go ahead and give it some command line arguments. And we'll see what it prints out. All right, so argv is going to print out a list. Check it out. It's got the square brackets. This is a Python list. The first thing in the list, item 0, is always the name of the program that it's running, or the name of the Python script as a string. And in fact, check it out. All of these things are strings. It doesn't matter whether they are numbers or whether they're Boolean. They're all strings. So I don't really care about this one. The item 0, I know what program it is because I'm writing it. So this is not useful information for me. But the good stuff starts right here. So the next thing I'm going to do is, instead of searching for hard-coded Subway, I'm going to go ahead and grab this restaurant right here. All right, that was garbage ASDF. But next time around this, I'm going to type Subway in. Instead of searching for that hard-coded version, I'm going to search for sys.argv. This is a list, and I want item 1 from that list. All right, save, and we'll go ahead and run this again. And we'll give it Subway and see if this worked. Okay, so here's my list of arguments, the name of the file, Subway is my search term, and it did find it. So it's no longer hard-coded to search for Subway. It's giving me X and Y. Let's do this one more time and we'll search for McDonald's. Yep, it's found McDonald's at coordinates 4 minus 3. Just a couple things that can go wrong. I'm just checking out my notes here. The set was one of the restaurants in the list too. Now if I do this, it's going to put the word the as one of the command line arguments and set as another one. So when it does this, it's now searching for the in the list. It goes through all the rows, it never finds it, and doesn't print out anything. So we could upgrade that later to deal with what if I search for something that's not in the data. But to actually get the set to work, all I need to do is put this in quotation marks. And then it will accept this as one piece of data, one element in the list, and then it can go ahead and find the set at -1, 0. All right, let me check my notes. One other thing, okay, yeah, one thing that may have gone wrong for you guys. If I do ls real quick, I see I've got the restaurants.csv, the Excel version, and my code. If you were to download the CSV file directly from the GitHub page where it's stored, a lot of times, particularly on Windows will replace the CSV with .txt for you and not tell you. If you're actually looking at File Explorer, I've got mine set up to display all the file extensions so that I can see when something goes wrong. This is not the default mode for File Explorer. Normally, it hides these from you. And it could easily replace that .csv with .txt, and then it won't be able to find the right file. This is really easy to fix. You can identify the problem by just opening up PowerShell and doing the ls to list all the files. It does show you the file extension right there. And if you do have, here, let me just make a text file. So suppose I downloaded it. I forgot the little arrow. I'll put some data in test.txt, and now I have a text file. And I'll pretend this was downloaded from the GitHub page, and I want to turn this into a CSV file. So all I need to do is use the move command. That's also going to rename things, test.txt, and I want to rename it test.csv. That's all there is to it. Now ls actually shows me that it's got the right file extension. So this is a problem you may run into. If you do, it's pretty easy to fix. If you struggle with any of these things, definitely just bring them to office hours. Be glad to help out. This is a really common mistake, or a really common error that sort of like just sneaks in and is really hard to spot because of the way Windows hides file extensions. All right, that's going to do it for me today. Have a great day, everybody. If you're watching this on YouTube and you would like to come join us for the live stream version of the lecture and have the opportunity to ask questions, you are welcome to join us. We're doing this every morning, Monday, Wednesday, Friday at 8 a.m. It doesn't matter which section you're in. You're welcome to come ask questions during the lecture, and we'd love to have you join us. All right, have a great day, everybody.